welcome back everyone. In this video we're going to discuss three important PyTorch functions that are going to be squeeze, unsqueeze and permuting. So let's start by importing torch, and we're going to discuss squeeze first. Oops, I did a typo there. Okay, let's start by discussing squeeze first. What is squeeze? By definition, squeeze removes all single dimensions from a given tensor. Okay, so that is just theory. So let's now try to understand how it works, or what do we use in it. Okay, so let's create a tensor. Let's just create a tensor here, a basic tensor. Let's just it's a single dimensional tensor. Here we go. So what will happen if we try to squeeze it? Okay, so let's try to squeeze this. Print x dot squeeze, and we run this. A second. Yep. Oops, looks like we made a mistake somewhere. Oh yeah, I forgot to add those brackets there. Okay, so it just prints the tensor, so there's nothing wrong with that. So I just mentioned that it removes dimensions from the given tensor, more specifically single dimensions from a given tensor. So what would be the dimensions, the number of dimensions in the tensor before squeezing and after squeezing it? So let's try to print the dimensions of x before squeezing it and after squeezing it. So this is before squeezing it, the number of dimensions, and this is after squeezing it. So what do you think would happen? Okay, so here we have a single dimension, and here we have 0 dimensions. So what do you think happened here? So if we notice here, there is a single dimension, is a bracket that gets removed after we squeeze it. So before it was like this, torch to tensor. I'm just gonna do this to explain it to you better. Now it's like this. It does not have the brackets after we squeeze it. So another way to explain with this would be, let's create this. So what do you think would happen if we do this now? Here we go. As you can see, it did not remove this dimension from this tensor. That's because this tensor cannot exist like this. It cannot exist like this. As you can see, it would just give out an error, but it can surely exist like this as a single value in it. Okay, so if we have extra brackets here, this dimension is doing nothing. Pretty sure it's just there. Now we try to squeeze it. I'm pretty sure, yeah, before we had 2 dimensions, now we have 1 dimension. This outputs 2, and this outputs 1. So in a nutshell, it removes any extra dimensions that are not needed to execute the code. So that's in a nutshell. I'm just gonna write it here in a nutshell. Oops. Squeeze removes any unneeded dimensions from a given tensor. So that's what squeeze does. So let's now take a look at unsqueeze. Now it's pretty obvious. It might be just the opposite of squeeze. It adds extra dimension to the given tensor. So let's see what it does. Here we go. Import torch. Let's create a new tensor. Torch dot tensor. Just a basic one, 789. Here we go. So let's print, or better yet, let's store the unsqueezed tensor in another variable. Let's create another variable called y. Torch.unsqueeze. Torch.unsqueeze. What do we want to unsqueeze? We want to unsqueeze x. Now, in this, you also need to specify the dimension that you are unsqueezing. So I'm just going to explain it to you just a moment. So you can just write it like this: 1, the dimension you want to unsqueeze, or you can write it like this: dim equals 1. It's basically the same thing, but I would prefer that you do it this way because it's way more intuitive. So let's try to run this, and oh wait, we need to print it too. Oops. Print y.endem and print x.endem. So this would print the number of dimensions x has and the number of dimensions y has. Let's try to run this code now. Wait, it didn't do anything. Oops, I forgot to save it. Yeah. So here we had one dimension when it was this the tensor was the same. X has one dimension, but y has two dimensions. Here we go. So what do you think would happen if we make this to 0? What do you think would happen? It's the same. So what's the difference that you might ask is? Well, the difference is where the brackets are added, the extra brackets are added. That's where the difference is at. So if we make it dim equals 0, if we unsqueeze it at the 0th dimension or the first dimension, 0 is the index, the brackets are going to be added at the outermost area of the tensor. They're going to be added like this. But if we make it to dimension equals 1, the brackets are going to be added like this. Oops. Just a second. The brackets are going to be added like this on each element of the tensor. So it essentially has an extra dimension. So let's try to print the unsqueezed version of x, or let's try to print y. Print y. As you can see, it prints 789 with extra brackets at the outermost area. Now let's change this to 1 and rerun the code. As you can see, it adds the extra brackets inside to each element of the tensor. So that's good to know. So that was unsqueeze for you. Now let's see what permuting does. Okay, permuting. I'm just going to clear out this dummy. Alright, permuting. What does permuting do? Now let's say I have a tensor x that is randomly generated, and the order that it is generated in is, let's say, 3, 4, 5. So it is a 3D tensor, 3-dimensional tensor that has the order 3 by 4 by 5. So there's nothing wrong with that. It's absolutely doable. Okay. Now, what does permute do? Well, permute changes the order that the tensor is being printed. So what do I mean by that? Well, it is now 3 by 4 by 5 tensor. But what if I want to make it a 5 by 4 by 3 tensor? Well, it is possible by the use of permuting. So let's try to replicate that in the code, shall we? Alright, let's create a variable y, and let's do this x torch dot permute x, and now we need to specify the order that we're going to be permuting this in. So we want the third dimension, which is the second, which is the 2 in index at the first 2, and then we want this one, which is at the first index at second. So we're going to write here 1, and we want this one, which is at the 0th index at last. So we're going to write 0 here. So this is how this works. So this the new order of y will be 5 by 4 by 3. So now let's try to print x dot shape and y dot shape and compare it. Oops. Yep. As you can see, the shape of the x tensor is 3 by 4 by 5, and the shape of the y tensor is 5 by 4 by 3. So that's good to know. But I'm pretty sure that some people are going to be confused at how this thing works right here. Don't worry, I'll explain it again. Okay, so let's say I have another tensor. I'm just gonna erase this. I have another tensor. Let's just name it random tensor equals torch dot random, and it's gonna be of the order 1, 2, 3, 1 by 2 by 3, or let's make it more simple. Let's just do it 1, 2. So it's a tensor that is of the order 1 by 2. That's pretty reasonable. Okay, so let's try to print the random tensor. Okay, we printed it, and it goes like this. It's a 1 by 2 tensor. It has 1 row and 2 columns. Alright, so what if I want it to be like this? I want it to be 2 rows and 1 columns instead of 1 row and 2 columns. So let's permute it. Random tensor equals random tensor. We're gonna overwrite it. Oops, I made a mistake there. Yeah, torch dot permute random tensor, comma. Now we're gonna specify how we want to permute it. So we want it to be like this. Just a second. Yeah, so we want it to be like this. We want the 1 to be at this place, and we want the 2 to be at this place. So what do? Well, we see what the indexes of the orders are. So 1 is at the 0th index and 2 is at the first index. So it's like this, 0, 1. So how do we interchange them? Well, we do this at like this here, 1, 0. So instead of 0, 1, we have 1, 0. So that was all there was to it. It's really simple. So now let's try to print the random tensor again. As you can see, now instead of having 1 rows and 2 columns, it has 2 rows and 1 columns. And now let's try to print the respective shapes of these tensor. As you can see, it swapped them. So that was all there was to it, and I'll see you in the next video.